number of keys that we had. If need be, we could calculate an average, a median, and a mode from all this, couldn't we? We could. I'm not going to do that though. I have some other data sets. I think the key, we've kind of killed the key data. It's kind of boring at this point. It's like, yeah, great, that's wonderful. Okay, let's talk about something else. Let's talk about cholesterol. I've been starting to go to the doctor once a year. Figure I'm 40, better start going. And they check your cholesterol, all kinds of cholesterol levels. HDLs, LDLs, ratios. HDL I think is broken down into 2 levels now. I think LDL might be 2. I'm pleading ignorance on this. They give you all these numbers. And they tell me things like, okay, this spike is, why is your LDL spiked here? And I'm like, well, I had a chicken burrito before I came in. And they said, why did you do that? I said, because you didn't say I couldn't. I mean, whenever you get blood tests done, they tell you to fast. And I called in for my physical, and they told me, 2 weeks before you get a physical, like, do I have to fast before? Nope. Okay. Chicken burrito. Boom. LDL through the roof running the test. My God, how are you walking, man? Like, and we finally figured out that I had a chicken burrito before I went in there. Why did you do that? Because they said I could. Saying I don't have to fast implies that I don't have to fast. I thought communication breakdown. I guess you have to fast. So anyway, LDL levels. Why do we care about LDL?
They're the bad levels.
Bad. What does it stand for? Low density lipoproteins. Thank you. Better word. Yeah. So you want this low. You want this low. Beautiful. Okay. So let's define low. What does low mean? Well, I guess ideally 0 would be ideal. I don't think that's even possible unless you eat nothing but grass. So if you can't be 0, what is low? Well, researchers are always interested in this kind of stuff, so they're constantly collecting data. So here are a sample of 100 American men's LDL levels. 100 American men's LDL levels placed for you in graphical form. So what they've done is they've gotten them below 3.25. What would you estimate that at? 1 or 2? Yeah, 1 or 2, somewhere in there. 3.25 to 3.75, about the same. 3.75 to 4.25, 12-ish, 11-ish, somewhere in there. 4.25 to 4.75, used to be 20. 4.75 to 5.25, 32. What you're doing right now is going to help you on the quiz for next week. One of the quizzes for next week has you reading a graph like this and pulling values off the bars. So just reference your scale and pull the values off. Please.
You talked about the scale grouping, so this one goes from 0 to 3.
I know it does, right? 0 to 3.25. The problem is I didn't make this chart. If I had made this chart, I would have broken that. These are all down in increments of 0.5. I would have broken these down 0.5 as well. So, in other words, if we were to find a technical average for this one, what value would we put right there?
3.25.
About 1.6 something, 1.625, I think, somewhere in that neighborhood. That's halfway. That most likely will be an underestimate because I'm guessing that this is probably closer to 3.25 than 0.
Like, how about 2.75?
Why 2.75? Oh, that's what I would have done had I set the chart up. I would have gone 2.75, 1.25, and so forth, 1.75 down, half each time. But what I'm saying is, given this, you'd have to use the halfway point. And now the problem, of course, you bring up a good point, is what do you do here, above 6.75? How do you find halfway between 6.75 and above? Right, what do you do? Well, the good news is, for this data point, you wouldn't have to, because there's nothing in that set. So you wouldn't even have to put a value on there, but what would you put on if you had to? Any ideas? There's no good answer for this, just so you know. I had to deal with it recently. Sean, help me.
The lowest stated value.
Say that again.
The lowest stated value of that range.
Oh, good, perfect. The 6.75. Very good, very good. That's one perfectly acceptable answer. Good. Any other ideas? I had to deal with this about 3 weeks ago, setting up data for student debt. Speaking of student debt. Any other ideas?
You could research to see what the lethal levels.
Sarah, that's what I did. When I was looking at student debt levels, they made a claim that the average student debt carried by a student in America is $27,000 some. And I said, I wonder if that's true. So I went on and I looked at some studies that were done, and they gave me all kinds of ranges of data. They said 3/4 of Americans carry some student debt, 1/3 of them have this much, and blah, have this much, and blah, have this much. And I got it all broken down in groups as well as I could, but I couldn't figure out the top. They said that 5% have over 200,000, which is a lot of freaking money. but I couldn't figure out what the top was. Like, that means it starts at 200, but what's the max? So I did some research. I did a bunch of Googling, and I found a lady somewhere that has $400,000 of debt from a photography school. And now she can't get a job. So she can't even pay down any of the debt. So I used that as the extreme. I used the 400,000. So exactly, that's what I did. I did some research, found what I could. Which means now, if it goes 200,000 to 400,000, you're going to use 300,000 as your middle. So that might or might not be accurate. The good news about that, coming back to the question, the good news about it is generally these endpoints in data like this, there's very few occurrences of the data in them, which means that if you're off by a significant amount, it won't matter that much overall, because there's only 1 or 2 data points in it. Is that fair? So you can be off egregiously as long as the data point itself is less populated than the rest. Fair? Good. Very good, very good, very good. Now let's talk about this data set. Thank you for the questions and the comments on that. That was fantastic. And not every question, the